This is class 2 of my arithmetic course. Today we're going to give an introduction to numbers. So let's get right into it. First we'll start with number symbols. So as you can see in the yellow, we have the first 10 symbols for the first 10 numbers. As you can see, something interesting happens after the first 10 symbols. And by the way, 0 is considered a number. A lot of people think that that's not a number. But I guess it's considered a number. Mathematicians like to consider it a number. And as you can see, the number 0 is used in 10 and 20 and bigger numbers and so on and so forth. So the first 10 symbols you see in yellow, but something interesting happens when you get to the blue. The symbols start to repeat. When you get to 10, here, the symbol for 1 and the symbol for 0 are used in the number 10, and those symbols were already used. So why is this? Why does it start repeating after the first 10 symbols? Well, I don't think anybody knows. But there is one possible explanation. How many fingers do you have? Well, most people have 10. Some people have more, some people have less, but most people have 10. And most kids, when they first learn how to count, they learn how to count on their fingers. So that's probably why we have 10 unique symbols, these symbols here in yellow, before we start repeating numbers. But we could start repeating numbers after 5 symbols, or 7 symbols, or 9 symbols. Why 10? Probably because we have 10 fingers. So you're not going to have to know that, but since we're starting from the beginning here with numbers, I just figured I'd give you something to think about there. But that's not really that important for the rest of the class. But what we're going to go over next is important, and that's place names and a place value. So here's a really, really big number. This number here is 567,862,593,142. Now, the 2 at the very end is in a particular position, and the 4 is right next to it, and the 1, and so on and so forth. The position of these numbers determines the size of the numbers. The 2 is in the ones place, and what that means is that there are 2 ones. The 4 is in the tens place. What that means there are 4 tens. 10 plus 10 plus 10 plus 10 is 40. So we haven't learned addition yet, so don't worry about that. But just know that these numbers get bigger and bigger as you go from right to left. This 1, the number 1, is in the hundreds place, so that number represents 100. And the 3 is in the thousands place, so that number represents 3,000. And if you break down the numbers, if you write the numbers in expanded form, you can see you have 2 plus 40 plus 100 plus 3,000 plus 90,000, and it just gets bigger and bigger and bigger. I had to make this number a little bit smaller. I had to make this number a little smaller than this number, because I couldn't fit the expanded form on the page. But if you break the numbers up, then you get very, very large numbers, as you can see down here. So if you add up all these numbers, then you just get something like 60 or 70 or 80. So that doesn't really make sense. Just, these numbers don't represent the same numbers because they're in different places. So that's place value. You need to memorize the place values. So you've probably already heard the word thousand, the word million, and the word billion. The numbers go all the way up to they go up to trillion, quadrillion, and even further than that. Now notice that each one of these numbers is broken up into three parts. There are 3 number groupings. Each one of those groupings is called a period. Now why is it called a period? I don't know. It just is. And you separate the periods with commas. So whenever you write a really, really big number, you always count 3 places over and put a comma, and then 3 places over and put a comma, and so on and so forth. Now the periods each have names. This is called the ones period. This is called the thousands period. This is called the millions period. And this is called the billions period. And so on and so forth. And it goes trillions, quadrillions, and all the way up. You're probably wondering if it ever stops. Well, I think it does stop at something like a Googleplex or something like that. But we don't really care about that. Now, why is it that all the numbers are put into groups of 3? I don't know. I don't know if anybody knows why. But these numbers are read in the same way. 567, 862, 593, 142. And you always have the name of the group. And then you have tens, hundreds, 10,000s, 100,000s, 10 millions, 100 millions, 10 billions, 100 billions. It's always 10. It's always the name of the period, then 10, and then 100. Name of the period, 10, 100. Name of the period, 10, 100. Now, why is it done that way? Again, I don't know. I don't know if anybody knows for sure. That's just the way it's done. So we start 567, and then we say, when you get to the comma, you say the name of the period, billion. So 567 billion, 862 million, 592,142. But the most important thing for you is just to memorize the place names. So let's go down, let's do some practice problems. Name the place and the place value of each underlined digit. 2 is underlined. And I'm going to go ahead and pan over here so you can see the place values. So what place, you can see the places and the place values. So what place is the 2 in? Sorry about that. Sometimes the screen jumps around for some reason. I don't know why. Well, it's 1, 2, 3, 4. It's the 4th number. So 1, 2, 3, 4. That's the thousands place. So that's the place name, is the thousands place. Let me get rid of that highlighter. Thousands place. Now, what is the place value? Okay, now it's in the thousands place, right? It's the thousands place. What number is there? Well, it's the number 2. So that means the place value is 2,000. So this stuff is very easy. I'm going to try another one, and then you can try the third one. So number 2, the 6, is in the ones place. Ones place. And how do I know that? Because it's the first number to the right. And the first number to the right over here is the ones place. And what number is in the ones place? Well, it's 6. So there are 6 ones. Now you try number 3. And again, use your place names and place value chart here. And when you come back, we'll do it together. So pause the video. All right, we're back. So the 3 is in the tens place. So tens place. And it's a 3, which means the place value is 30. 3 tens make 30. All right, number 4. See if you can try that one. And pause the video, and when you come back, we'll do it together. All right, we're back. The 8 is the 3rd number over. The 3rd number is this number here, which is the hundreds place. So the place, the name of the place is the hundreds place. And what number is in the hundreds place? It's 8. So that means the place value is 800. Try number 5, and when you come back, we'll do it together. Pause the video. All right, we're back. The 9 is the 5th number over. So looking at your place value chart, the 5th number over is this 9, which is in the 10,000ths place. So the place name is 10,000ths. 10,000ths. And what number is in the 10,000ths place? 9. So that means the place value is 90,000. Right, so why don't you try number 6? Number 6 is a big number. See what you can do. Pause the video, and when you come back, we'll do it together. All right, we're back. The 3 that's underlined is in the eighth number over. The 8th number over is the 6 here, which is the 10 millions place. All right, the 10 millions place is the name of the place. And the place value, there's a 3 there, so the place value is 30 million. Now, why don't you try numbers 7 through 12, and when you come back, we'll do them together. Actually, I'm going to go ahead and just do them right now, and you can keep the video going if you want. I'm not going to say anything, so you just keep going, and we'll do them together. And then when you're done, you can go over and look at the answers. All right. So if you're still working, you can pause the video. I'm done, so you can... now remember, this is not a race, so don't let me rush you. But when you are done, you can look at my answers to check. Now, number 10 is kind of a tricky one, so watch out for that one. Pause the video, and when you come back, check the answers, and we'll go on to the next part of this class. All right, we're back. Now we're going to learn inequality notation. This symbol means is greater than. This symbol means is less than. So this expression here means 9 is greater than 5. And the way that a lot of students memorize this is if you write your greater than symbol, this is your greater than symbol here. And if you draw a Pacman, the greater than symbol wants to eat the bigger number. All right, so that's how I always remember which direction the symbol goes. I can't remember it otherwise. I just can't. That's the best way for me to remember. So 32 is bigger, so your greater than symbol goes this way. And so on and so forth. Now here's an example where it looks like this number is bigger because there's all these 9s. But notice that you have the same number of digits, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So when you have the same number of digits, to figure out which number is bigger, you look to the number that is farthest to the left. That would be 2 in this number and 1 in this number. So because there's a 2 in this number, that means that this number must be bigger. Again, if you're looking at two numbers that have the same number of digits, the number furthest to the left, whatever number is furthest to the left is bigger, that number must be bigger. Because this number represents 2 million, but this number is not quite up to 2 million. It's 1 million and then 999,999. So if you add 1 to this number, you get up to this number. So on this number you have 9 plus 90 plus 900 plus 9,000 plus 90,000 plus 900,000 and plus 1 million. But this number, you have all of those numbers all added up plus 1 to 2 million. So if you're not getting this, that's okay. We're going to do some practice problems. Let's do number 13. The directions say write an inequality. That means this symbol or this symbol. Write an inequality symbol between the two numbers, these two numbers, in each pair to show which number is bigger, or write an equal sign if they are of the same value. So if these were the same value, then we'd write an equal sign. That means they're the same number. Now this number in 13, these two numbers have the same number of digits, 1, 2, 3, and 1, 2, 3, which means all we have to do is look at the number farthest to the left in both numbers, which is 8 in this number and 7 in this number, and ask which number is bigger. And obviously the 8 is bigger, so Pacman wants to eat. He wants to eat the bigger number. All right, and we have the same situation here. We have 6 digits in each number. And by the way, I don't know if I mentioned the word digit. The word digit just means number. So that's 1, 2, 3, 4, 5, 6 digits. No big deal. The word digit is just another way to describe numbers. So you look to the number farthest to the left, which is 2 in this number, 3 in this number, which means this number must be bigger, and Pacman again wants to eat the bigger number. He's going the same direction on that one. All right, now in this case, we have something different because one of the numbers has 3 digits, whereas the other number only has 2 digits. And by the way, I'm going to erase this. I'm going to change places because in the other problem, Pacman was going in the same direction. Wait, what did I just do? I just wrote the same exact thing. I meant to write that. All right, so one number has 3 digits, the other number has 2 digits. If that's the case, then the number with more digits is always bigger, and Pacman wants to eat the bigger number, right? By the way, I don't know if you've played the video game Pacman, but that's a very old game where this little robot thing goes around and eats stuff, and he's called Pacman. A lot of people may know what I'm referring to. If you don't know what I'm referring to, no big deal. It's just an old video game. That was back in the days when video games were just getting started. All right. So why is it that if you have more digits, then the number is bigger? Well, because this number represents 300 plus 70 plus 6, whereas this number only represents 80 plus 9. So obviously 300 is way bigger than these numbers, even if you don't consider the other two numbers. That's just the way it is. And you're going to learn this as you go along. All right, now here's an example 17 where you have the same number of digits, and the number farthest to the left is the same in both numbers. So in that case, you just choose the bigger number that's left over. So 7 is bigger than 6. So Pacman wants to eat the 47. So at this point, you're probably starting to get a feel for how this works. So now, go ahead and try number 19 through 25. And I'm going to do these along with you. But remember, it's not a race. So just if I finish, then I'm going to tell you to pause the video and you can catch up. So go ahead and try number 19 through 25. Actually, I'm just going to wait for you, because there's not really much for me to do. All right, so we probably don't want to waste video. So if you're still going, that's okay, but just pause the video, because I'm going to start giving you the answers. For number 19, 37,000 is bigger. Number 21, 2,999 is bigger. And 23, again, the same inequality. And again for number 25. All right, so those just happen to be all going in the same direction. Now for 19, if you're wondering why, we had 3's. So we have the same number of digits. We have 5 digits in both numbers. And the number furthest to the left is 3. But if you look to the number next to the 3, you have a 6 over here in the left, and you have a 7, which means this number must be bigger. Now again, I know what you're thinking. You're thinking, well, there's just a bunch of zeros here. This number has to be bigger because it has 420. Whereas this, you just have to have a bunch of zeros. But again, it's a number farthest to the left that matters. The 7 is bigger than the 6, which means that 37,000 is bigger. And Pacman wants to eat that number. And the same is true for all these numbers. Don't get confused by numbers that look the same. The 2, you have 28, which is the same in both numbers, but you have 0, which is the different number that's farthest to the left, and you have 2, so this number is bigger. So again, you're going to get the hang of this as you go along. Now the reason I wanted you to stop at 25, and I just realized that I was skipping numbers, but that's okay. Well, I'm sorry about that. I should have done these. So let's go ahead and do these. So less than, less than, less than, less than. These are all less thans. I wonder why I did that. Now look at number 26. Number 26, you have a 0. Any positive number is greater than 0, so this number must be greater. Now, in the next course, pre-algebra is the course after this course, which is what you're going to be taking in the next 3 or 4 months, or 2 months, depending on how fast you want to finish this course. You're going to learn about negative numbers in pre-algebra. But in this course, we're not doing negative numbers, so there is no number that is smaller than 0. Not even fractions are smaller than 0, as you'll learn when we go into class 11 of this course. So now, number 27, there's something interesting. For 27, these numbers are both the same. So if the numbers are both the same, you write what's called an equal sign. That means the numbers are the same. And those lines are supposed to be horizontal, but I don't have a very steady hand. All right, so that's inequality notation. Now, if you didn't get enough, oh, I forgot to do these. So this number has more digits, so Pacman eats that number. And this number, the number farthest to the right is a 2. The number farthest to the left is a 2. The number here farthest to the left is a 1, so this number is bigger. All right, so we're done with the inequalities. Again, these symbols are called inequality symbols. So if you were to read these statements, you would read 89 is less than 376. 47 is greater than 46. That's how you read that math statement. Like I said, the most important priority for this course, or the most important thing that we're going to do in this course, is learn how to read and write mathematics. That's the number one priority of any math course, is to learn how to read and write it. The second priority, obviously, is to learn the theorems, the concepts, and the algorithms and definitions and postulates and all that type of stuff that we're going to learn as you go along in the entire math sequence, from this course all the way up into college. All right, so now we're going to learn a few more things here. These numbers are all written in standard form. That's what they're called, standard form. That's when you use symbols to write the numbers. This number here is in standard form. That's the number that we talked about before. 7,862,593,142. That's the smaller number. We used a bigger number, but I couldn't fit it on the page, so that's called standard form. But there's also word form. You can also write it using words. 7 billion, remember you always say the period name right when you see the comma. The period, the comma, so that, for example, this comma, you would say million. You would always say the name of the period that precedes it. This is the million period. So when you get to this comma here, you say the period that precedes it, which is million. When you get to this comma, you say 1,000, because that's the period that precedes it. And the period that precedes this comma is billion, so it's 7 billion. So as you can see, I've color-coded this. 7,862,593,142. All right, so that's how you convert a standard form number into word form. Now, this is not an English course, so I'm not going to tell you how to spell the numbers, or I'm not going to teach you all the names for the numbers in terms of 72 and 11 and all that type of stuff. But there are some interesting things to know. Obviously, the names of all the first 10 symbols are all unique. Then when you have these 3 symbols, you have unique names, and then you get into the teens. Those have unique names, in the sense that there are different variations. And then you get into the numbers where you always put a T and a Y at the end of the number. For example, 21, you would put ty at the end of the word. Well, actually, that's not a good example. For the first for 20, 30, 40, 50, for the first 1, 2, 3, 4, for the first 4 multiples of 10, they have, again, unique names. Now, why is that? I don't know. They just have unique names. But when you get into 60, 70, 80, and 90, it's the same number. It's the same word, 9, 8, 7, 6, but you put a ty at the end, 60, 70, 80, 90. Now, why is it that you don't do that for 20, 30, 40, and 50? I don't know. I don't know if anybody knows the answer to that. But these are all things that you're going to learn. And again, this is not an English course, so I'm not going to teach you how to spell the words and all that type of stuff. But we're going to get some practice with converting from standard form to word form and word form to standard form and so on and so forth. Now, notice when you write a 2-digit number, for example, 93, you always put a hyphen in between the two numbers. 42, 93, 62. You always put a hyphen in between those numbers. Also notice that you don't want to put any commas. There's no commas written. And there's no and in any of the in this word form number. Mathematicians don't like to say the word and until you have a decimal point. For example, if you had 76.3, they would say 76 and 3/10. But again, you haven't learned decimals yet, so you don't have to worry about that now. But don't write any ands. Now you're going to hear me say 7,862,000,000. Sometimes I'll say the word and without even knowing that I'm saying it. Technically, it's not really wrong. It's just not what mathematicians prefer. They prefer to say and when you write a decimal. So don't say the word and in this class. Only say the word and when we're going to go to decimals later on. All right, so let's practice. Write the following numbers in word form. So this number here is in standard form. We're going to write it in word form. So we start off with the number farthest to the left, which is 3. And let's look at our place value chart. The number furthest to the number that is 4 places over is the thousands place. So that is going to be 3,000, and capitalize the first letter, 3,000. Now notice I say the number, when I get to the comma, I say the number of the period preceding it, which is the thousands place. And then I say the other number, 600. And I'm not going to write an and. 70, and it's a 2-digit number, so 70 with a hyphen, 8. And I don't know why that box keeps coming up. Sorry about that. Now the 4 is the number farthest to the left, and that number is in the 10,000s place. So, and it's actually a 2-digit number in the second period starting from the right. So that's the thousands period. So it's 42. And again, it's a 2-digit number, so that you need a hyphen. 42,000, the comma tells us to say the place of the period preceding it, which is the thousands period. 42,915. I really don't know why that box keeps coming up. It's starting to get really annoying. Don't worry, I'll figure it out later. All right, number 31. Now the number farthest to the left is 1. So that number is in the 100,000s place. Again, you can see this by going back to your place chart. And you can find a place chart. You can take a screenshot of this. Push the Windows button on your keyboard, and then also the part screen button. The Windows button should be to the bottom left, and the part screen button should be to the upper right. Hold down the Windows button and push the part screen button on the upper right, and that should take a screenshot if you have a PC. Now, if you have a Mac, it's something different, but that's okay. Just go on Google, type in screenshot with a Mac, and it'll tell you how to do it. Take a screenshot, and that picture will go to your files. You can go to your files and pick up that, open that file and see that picture. I don't know if that's really going to help you because you still have to use the screen to see what I'm doing here. You can also go on Google with your phone or or whatever your device you have, so you can see the place values as you're doing this. So the 1 is the number farthest to the left, and that's in the hundreds place, or excuse me, the hundred thousands place. So it's 1, because it's a 1, 100, and then 23, 123. Then you say the number, the comma, you say the number of the period that precedes the comma, which is the thousands place. 123,000s, or excuse me, 1,000. 575. All right. So now we have a really big number. Look at this number. Number farthest to the left is in, if you look at your place value chart, number farthest to the left is the millions place. So how many millions? It's 6 million because there's a 6. So we say 6 million 853, and then we say, we have a comma, so we say the name of the period preceding it, and the name of the period preceding, when we got to the comma here, we used million because that was the name of the period preceding the comma. This is the millions period. And again, you can see this by looking over at your place chart. 6,853,000. That's as far as we've gone so far. And then 299. All right, why don't you go ahead and try 33, 34, and 35. And then when you come back, we'll do it together. Actually, I'm going to go ahead and just start these while you try those. And if I get done before you, you can just pause the video. And by the way, we should be rectangling all these answers. I forgot to do that. Remember, always rectangle your answers. Oh, whoops. That was an answer. Number 35 was kind of a tricky one. Now remember to capitalize the first letter of the words. All right, so go ahead and pause the video if you're not done yet, and you can check all my answers when you're done. I'm going to go on to the next problem. So when you're done, actually I think that is the next problem. That is the last one of those problems. Actually, no, we've got more of those. Yeah. All right, so pause the video, and when you come back, we'll start with number 36. All right, we're back. Number 36. Go ahead and do 36 through 39, and I'll go ahead and do those with you. In fact, let's do this first one together. This third period here is the millions period, so you say 9, and then the comma is when you say the name of the period preceding it. So 9,600,501. And remember to capitalize the letter of the first word. Remember to rectangle your answers. Number 37 is kind of a tricky one. I don't know why that box keeps coming up. I wish I could disable that program somehow. So far, Microsoft hasn't done anything to help me with that. I tried to contact them. I don't see any reason why that would be coming up, that box. All right, so if you're still working, go ahead and pause the video. And when you come back, look at the answers here. And then we'll go on to number 40. All right, we're back. Go ahead and look at those answers. And pause the video. And when you're ready, we'll go on to number 40. All right, we're on to number 40. Write the following numbers in standard form. I wrote follow instead of following. Write the following numbers in standard form. Now, standard form is with number symbols, right? This is word form, and this is standard form. So we want to convert from word form to standard form. So 5, that's pretty easy. That's just the symbol 5. 72, that's a 2-digit number. 7 and 2, 72. 856, that's a 3-digit number. 856. And 9, that would just be 9. 43, 43. 121, 121. Now we go to some bigger numbers. 2,864, 2,000, and we put a comma for the name of the period preceding it, so that's thousands place, so 2,864. And why don't you try number 47? And pause the video. When you come back, we'll do it together. All right, 58,000. 58, comma, for the 1,000, the name of the period preceding it. 719. All right, number 48. Try that one, see what you can do. When you come back, we'll do it together. All right, we're back. 58,000. 709. Now, I did that on purpose. I tried to make this problem almost exactly the same as this problem, but there's just a slight difference. Instead of saying 58,719, I said 58,709. So those numbers are pretty similar. Just a slight difference there. So number 49, try 49. Pause the video. See what you can do, and when you come back, we'll do it together. All right, we're back. 603. Now, I almost said 603. Again, you're going to hear that a lot in our society. But remember, mathematicians don't want to say and unless there's a decimal point there. So we're not saying and in any of these problems. All right, try number 50. And when you come back, we'll do it together. All right, we're back. 89,577. So if you got that one right, pat yourself on the back. If you didn't, we're going to do a lot more. Actually, I think we only have 6 more to do here, and then we'll be done for the day. I'll be done for the day. You still have to do some homework. I know it's not fun doing homework, but remember, homework is the most important part of this course. If you don't do the homework, I promise you with every fiber in my body, you will learn nothing in this course. So homework is the big battleground for you in this course. Try number 51, And when you come back, we'll do it together. Go ahead and pause the video. All right, we're back. 5,350,640. Now notice that I wrote a comma every time I would say the name of the period. Million, we have thousand. Those are the names of the periods. And if you go to billion, that would be the name of the next period over here. And then trillion, and then quadrillion, and so on and so forth. Now again, you're asking, well, how far does it go? Well, it just goes forever pretty much. I think Googleplex is the highest number, something like that. I don't know. Don't care. All right, number 52. Try 52, and I think 52 is almost exactly the same as 51 with one slight difference. See if you can figure it out. Pause the video, and when you come back, we'll try it together. All right, we're back. 5,305,604. Again, 5,305,604. So this number is almost exactly the same as the number in problem 51, except at the instead of saying 5,350,640, instead of saying 50 and 40, we're saying 5 and 4, you see? It's really easy to get mixed up there. Again, this number is 5,350,640. You're saying 50 and 40. But in this number, you're saying 5,305,604. Not 50 and 40, but 5 and 4. All right, so those numbers go in the last position in the periods, whereas these numbers go in the second period in the periods. Again, a period is a grouping of three. First period, second period, third period. This period is called the ones period. This period is called the thousands period. This period is called the millions and billions and trillions and so on and so forth. All right, 348 billion. 348 billion. 308 million. 348,308. Wow, that's a big number. Now you try number 54, pause the video, and when you come back, we'll try it together. All right, 97 billion, 907 million, 997,907. That's another huge number. All right. Number 55, 12,000,003. See if you can do that one. Pause the video, and when you come back, we'll do it together. We only have 2 more problems left. So you're doing good. You're doing good so far. 12,000,003. All right, so here we go. 12,000,003. 12 million. And then you have to go all the way to 3. So that was kind of a weird one. We didn't say the name of this period because there were no numbers in that period. There was all zeros. So we just said 12,000,003. Number 56 is going to be kind of like that one. See if you can try number 56. And when you come back, we'll do it together. Pause the video. All right, we're back. 10 billion, 10 billion, 800 million, 800 million, 1. So if we're going to have 1, then we have to put the thousands period, then the ones period with just a 1 there. Now if it said 10,800,000,010, then we'd have to put the 1 here. If it said 10,800,000,100, then we'd have to put the 1 here, and so on and so forth. So in the homework, you're going to have more practice here. And you can go on the internet and you can find plenty of these types of problems. There's just a never-ending number of problems. Here's the homework. So you can take a screenshot of the homework. Go ahead and take a screenshot of this page, and then this page, and this page, and this page. Now you notice that I have the answers rectangled over here. And you're probably going to think to yourself, well, you're giving me the answers, you're teaching me to cheat. Well, what I'm doing is teaching you to check to make sure you did the problem correctly. That's what I'm teaching you. Okay, if you do the problem and you don't even bother to check to make sure you did it correctly, that means that you don't care if you did the problem correctly. And I understand that a lot of students really don't care, but if you're going to take this class, you better care, because that means if you don't care, you're wasting your time. So you want to learn all the material in this course and make sure you got it down. So check all your answers. Make sure your homework is correct. Make sure that your homework is done completely, correctly. Do every single problem. Now remember, I promised in the first class of this course that I would never give you more than 30 problems, and I would never give you less than 15. So you have 29 problems here. And be sure to do your homework and make sure everything is orderly. Put your name, date, course, a title for the homework, and show everything. And remember, if you don't do the homework, then you can't go on to the next class, and you will fail this class. You will fail this entire course if you don't do the homework. So that's the end of class 2, and I'll look forward to seeing you in class 3.